Thank you for coming to this talk. I tried to choose some kind of a buzzword title for this one. I'm not sure I managed to do that properly. So my name is Daniel Molnar. I work for Microsoft here. Used to work for 600 We're based in Berlin, and we've been acquired by Microsoft as the makers of the Wunderlist. And I'm trying to talk you pretty condensated, fast on what we did in the last 1 year. So maybe you can have some embarrassing questions to me that I will try to answer at least. I'm not sure how much you are invested in the Judeo-Christian religion in general. It's a pretty interesting topic because there are people throughout the history of human life who claim that they have been talking to God. And how can one imagine, talking to God, the big bearded man, coming to you and say, "Hey, what's up?" Actually, it's a bit more complicated because it seems like that God doesn't really have a body. So how do you talk to him? It's a voice in your head and stuff. There is an angel who's called the Metatron, and everybody who claims that they talk to God, they actually talk to the Metatron. He is the voice of the God. So right now, today, I'm trying to be just channeling the one and the real only message from the team I work with. So I'm not the sole crazy person in this one. We're at least, throughout the last years, we were 4 altogether. Torsten, Balázs, and Bence, who contributed to this effort when I'm presenting to you here today. And I have to say that I'm standing on the shoulders of giants. These people made this impossible thing possible. And so I'm going to talk about where we come from, what we did plan to do, how did we actually refactor a system in flight, and how to fix it to make it really fly. And that was original plan to talk about this, when I realized that I don't have any buzzwords in my presentation, so I added buzzwords at the end. Maybe they will not be completely unrelated to the topic I'm talking. So this is what I think about the State of the Union. If you were to any other talk on this conference, maybe they will disagree with what I'm telling you. But I might be statistically mean, and there is a pun intended in this one. So where we come from, how big we are, how small we are, what do we roll with? It's called Wunderlist. It's a productivity app with 21 million users. It's not small, it's not big. It's kind of a decent size. We're doing it for 6 years with 70 people, actually 67. And in the past, we did one big migration from a monolithic Rails to a polyglot microservice approach. And we use all kind of stuff on the backends like Scala, Clojure, Go. Mostly, these are the important languages, and the stuff is running on AWS. I brought you colorful things. This is it has arrows and color spots. This is our backend infrastructure that you talk to something that's web service. We identify you, and there are services that are facing you, and there are services that's facing the backend. It's coming back then, and there's the brain that knows everything and moves messages in queues. So I would say it's complicated. It's working, but it's complicated. This is polyglot microservices. This is the map of Poland you can see in the background. But actually, these colored circles are all different microservices, and the size of the circle shows you how many of them are actually running at the same time. There's lots of them. It's they are in the numbers of hundreds at any given moment, and there are a lot of different ones. It's they are not the same. I had to add one tweet in there, and I presume that if you do run microservices, you can agree with this finding that really running microservices is fun, but running data on them is even more fun. The data mostly is in Postgres databases. I think there was a time when we had the single biggest running Postgres instance running on AWS. And every microservice has its own database, and there's lots of concurrent talks here and there, and they're big. So we had to deal with this. The context of how big it is really in terms of shuffling things here and there and moving things. We collect events from the client devices, we collect events from the backend logs, and we try to mirror all production databases. We kind of try to play by the book. There's nothing special about it, I would say. But we ended up as it's in fashion now these days, making self-service data for everybody. So actually everybody in the company has access to data, can deploy things into the data flow. And yeah, so you can see that 125 million per day, not small, not big. The compressed logs, the output is like almost 400 gigs per day, so not the input. And we do this with old school technology. We have chosen boring technology explicitly. We don't use anything else, I would say. Yeah, there are some patches here and there, but we rely on things that are around like for more than 40 years. We use Unix, Bash, Make, crontab, SQL. Why? Why are we doing this? I think we can blame Jeff Hammerbacher. He was doing a data science course sometimes back in the days, and he was fondly mentioning that, this ETL is easy. You can do it with Make. You just some dependencies. And we took his word, and we said, yeah, let's try. And we kind of started to like it, and we're still sticking to it, and it still survives with us, because as it's written, like, it is actually the documentation. The code is the documentation. It handles the dependencies, the retries. You can test the stuff even on your local machine. It's good. It solves parallelism, if you want. And you can see in the Git log what happened, what's there, what was the state of the union a month ago, 3 months ago. So if you figure an error happened 6 months ago, you can see what was the state of the system. There's nothing fancy, magic about, this is a make file. The funny stuff starts here. There's like a run SQL template Ruby. Oh my God. That says a Redshift dialect and like credentials and configs and files and scripts and stuff. Yeah, we use Redshift. I get to that a bit later. We actually made an ETL system out of this blob. That's something above Make that uses cron. We kind of glue it together with Bash. And we have one magic that's using Ruby's ERB scripting language to inject variables and conditionals and like magic and logic into SQL. Because we have to use, we had to use Redshift, which is not like a really smart SQL thingy. We had this crazy idea that make a shell around the shell so we can track what's going on. So it's actually having a meta shell to be able to provide us information, how the ETL is going on. It has a small interface in Flask, also locally testable, and it's open source. What's out there in the open source is the one thing that we run in production, so you can trust it. Yeah, when I talk about like injecting ERB into SQL, it looks like this. Nothing really complicated, but it kind of helps a lot in our daily life when we have to move data. Again, the interface is not fancy. You can see like some kind of Gantt diagram that how things rolled. It's green if it's OK, it's red if it's bad, and you can investigate all of the steps. How did they behave? And also, we kind of tied in some kind of data quality measurements in there. We are obsessed with data quality as far as we got lots of microservices, and anything can fail at any time. You have to be pretty sure that whatever it's in there is the reality. So it does on the fly. I mentioned Redshift before. Our running size is like 10 TB compressed aggregation. It's not big, not small. You don't want to open that file if you talk about the actual dump. And we got the 2 clusters set up. When we started to grow, we were thinking that maybe we're going to outgrow Redshift in the sense of like having all the events in one SQL database. We still have all the events we had ever from day 0 from backend and frontend in one table. It's working. That's why we have a cold storage. We were thinking about like having some kind of hybrid approach, but then we realized that to keep it homogeneous, it's just much better. It's less of a context change if you want to do things and fix things. So right now we have a big, slow cold storage that has every event, what we had ever. And we got a hot, that's kind of the data warehouse, where we move over an aggregation of the events and everything else that we need to do the queries. Arrows. Everybody likes arrows. I think this is like a pretty simple and default setup. It's the state of the union from last year, December. So we log the backend with like a Nginx proxy. We try to track what's happening on the client side and in the emails we send out. The logging thingy goes to S3. We had a Elastic MapReduce job that's kind of crunched the stuff. The client-side events went to the SQS AWS service via the SNS thingy, so it's a queue. And we had to dump this queue, and everything ended up in S3. That goes to cold storage. And then, again, we try to move everything into the hot. And then everybody can access the things with chart.io and figure out what's happening, making SQL queries, even like a drag and drop, or writing them as you wish. So that was the State of the Union last December. I'm not sure you are feeling the fun and excitement now. I'm telling you that we're going to move over this whole architecture from AWS to Azure. But if I add some more attributes, that throughout this whole process, we had 1.5 engineers given at any moment of time, I think you get the sense that it's going to be fun. That also means that we took the business requirements a bit more straight than it's usual. I say that I have mixed feelings about Gartner and Gartner reports, but the concept of total cost of ownership is something I can vibe with. So like if you put something into production, you need to be able to maintain it. And also, the sizing of the team shows you that we can do really like 24/7 error handling, and if something fails, it has to be resilient and stuff. Thank God we didn't have like forensic analysis in our scope, so we kind of could skip that part. We were more like going the analytical direction. And I think the main rule we had is like if we can remove something, then we will. So again, just reflect. I don't know if you are familiar with I try to pronounce his name properly, Maciej Szeglovski, I think. He's from the Pinboard fame, and he had a talk recently. It was called like "Haunted by Data." It made some waves in the data community that this guy just like doesn't like big data and stuff. And he had the concept of the bucolic data landscape. You know, we got like streams and the data lake and the logs and the warehouse. It's somehow just like very rural. And my friend and colleague Bence took the time and actually did this. This is the bucolic data landscape. It's like the Hadoop Jenga you have here. Everything on top of it. You got the data lake and Azure and like data pipelines and the rest. There's like Luigi up there. And the Power BI. Some things we actually built, like small animals here and there. And I figure that it's kind of complicated. It's really nice. We have it printed, a frame. So if you want, you can have it. I was thinking about making some kind of a small trivia game in there, and like you can have the physical copy. So we thought that, yeah, make it simple. So praise the Lord, James Mickens. And what we did is we tried to refactor just in flight. Again, we have to simplify things. We thought that maybe we could survive just removing the AWS specific parts and just try to cram it into Azure. And we had to remove unnecessary complications like Hadoop, because I just really don't want to move over EMR job to Azure. That's something you want to do. And yeah, so you can see that I'm actually just giving it away. So what we had an idea is like, take what we want, take what we have, and just clone it in Unix on Azure. So back. This was the first State of the Union I had. I will try to make a small animation here. I think I managed. So what we did actually is figure that it's enough to use the logs coming from our internal Nginx proxy. And we made a new service called Junior Beaver. Previously, our Elastic MapReduce job was called Mr. Beaver, because it crunches logs. I'm sorry. And we were like, can we do it without Hadoop? So we replaced Hadoop and Scala with make and PyPy. The code is in Python. It runs in PyPy, and make handles the parallelism. And it does what you kind of expect from such a service. It kind of has a MapReduce functionality. But it's configurable in YAML files. And we kind of started to believe this saying that big RAM kills big data. Instead of having lots of small machines switched on and off on demand, we were thinking that maybe you could have like one machine with like more RAM, see how it goes. And we did our benchmarks on this thingy. Our Elastic MapReduce job had 600 vCPUs, and GeneralBeaver has like 8. But like an Elastic MapReduce job is something like coming on demand, so it's not fair to just compare vCPU count, I would say. Let's compare like the working hours, actually. The MapReduce job kind of ran for an hour. GeneralBeaver runs much more, but still, it's like 1/10 of consumption. And you can even call it real time, because we can run batches every 20 minutes if you need. Animation again. Whoop, whoop, whoop. This was a pain point all the time, I have to tell you. Queues are pretty nice because you can just like throw things on them, and you forget about them, and you're fine. But getting things out of queues, that's where the headache starts most of the time. With the SQS thingy, we actually had to use Ruby to get things out because of our limitations and the time we built things that was only reliable binding an API. But then, the parallelism kind of was depreciated. Things gonna start to happen, and we were thinking that, do we need queues? We were inspired, I think, by a guy called Marcio Castillo, who had a funny article on Hacker News about handling 1 million processes, requests in Go per second. And that tutorial made us think that, why don't we just like try to make something in Go and change our already existing Node.js small event collector thingy to Go, and just try to write into files. Why not? What bad things can happen? We tried to implement some of the fidgety things, like handling sessions and strict order of events, which is hard because, as far as we know, the concept of time is something is always a bit tricky if you are working with distributed systems and clients that are either connected or not connected or somewhere in the world. And when we had this idea, then it makes sense to just like support all kind of targets. Meaning you can actually write into queues if you want with this thing. You can write into AWS queues or Azure queues or Azure Blob Store or S3, doesn't care. And I figured that we can do 6 million events per minute on a single 4 vCPU thingy. That's like small. And you can send protobuf if you're sane. But if you're really in a hurry, we will try to handle your JSONs also. It's going to be slower, definitely, but life is hard. This thing is also open source. You can check it out. So for the benchmarks, vCPU count. Our previous homebrew tracking was running on 12 very small machines. And nowadays, Hamustro is running on one that has 4, or either 2 that has 2 cores. This is a different comparison, but also makes sense if you think about how much data you can cram into a queue, or how much data can you cram into like a file. It's no surprise, but with the same hardware resources, you can have pretty much difference on this one. And it's not about the machine, actually. Queue is a queue is a queue. We have to talk a lot here and there. Why just cram stuff in files and just upload them? And then we had that crazy idea again that this is a 4 vCPU computer. It's like a small thing. Can we just deploy it on the Raspberry Pi on my desktop, like on my table? Like, what will happen? It worked. And we realized that this RPi has more power than we need now for a Wunderlist. And then we started thinking again. This is one kind of thing that consumes lots of resources. We got this machine as like a client event tracker. We got a machine that runs the ETL. It's like in a make. It's like a Unix bash. It's not eating much CPU. I would say and we get two that we can put the log cruncher on. So you can have a fully featured data stack without a data warehouse for a company the size of us on 4 Raspberry Pis with like an investment of $150. I'm just saying. If I want to be like really pathetic, which I actually want to be, I like this idea because it gives access to data and data processing capabilities to people who don't have much resources. I like that. Like, you are an NGO and you want to track all the gazelles in Africa. It's OK, you can do it. With a small thing like this, and this doesn't have any moving parts, and you can glue together 3 of them if some of them fails. You don't care. That's about the love and dream. So how did it happen actually in reality? So the fix-up part. So we try to change the parts in a way that they should be agnostic, where they are running. And we try to map them together. So we say, like, OK, we forget about the SQS thingy, and we just use blob storage instead of S3. We use the Azure SQL data warehouse instead of Redshift. We still evaluate Power BI. We'll see how it will go. And we actually removed our own tracking with a new one that can run in both places. This is a proper equal sign, I would say. We're running all kinds of tests. We did our homework and the benchmarks. And also, I would say that I even like Azure Blob Storage more in terms of like the granularity of access control. What can you do with it? Speed-wise, it's pretty much the same. We spend much more time figuring out how Amazon Redshift and Azure SQL Data Warehouse compare, because they are different beasts. Redshift is coming from more like this get an axe and like just slash it approach, but it's like crack because it's fast, it's really good. It technically scales linearly. You're happy with it? While the SQL Data Warehouse is coming from like the enterprise environment where you have all the quirks and jingles and whatnots. And that also means that you have like proper stored procedures, which you don't really have in Redshift. That's why, for instance, we had to use like the ERB code injection with Redshift because we wanted to have like more complex things. Data warehouse could handle it. Both of them has like good and bad points, I would say, and they are not the same. But we had to figure out how to change small things here and there to replace one with the other. And there's going to be an upcoming benchmarking post from the data warehouse team. We work them. They are based in Los Angeles, and they're just about to release like the proper Azure data warehouse. And they're going to release the official numbers, but it seems like that they are kind of equal. And if you want to do like complex queries, the Azure data warehouse is even faster than Redshift. So tooling. We want to deploy Unix thingies in Azure, which is like, in theory, possible, technically possible. Still, we have to like fill some gaps here and there. So we did something that's similar to like the S3 command that can move things here and there. It's called Azure command. It's open source. You can use it if you want to. And if you're familiar with like the command line pSQL thingy, we did something that's very similar. It's behaving in a similar way, like a Unix similar way, to connect to Azure data warehouse and also to the Azure SQL Server. Animation time. So this is the AWS thing, the more like stricter, no much hustle approach. And this is the Azure thingy. That is kind of the same things. Yeah, there's another buzzword called Weasel. That's the log processor, but it technically does the same things. We had to adopt our SQL approach when changing to the Azure warehouse. I started to talk about this. We had to have different loading strategies and they have different compression methods. They have different sharding, indexing, whatnot. There are pretty good things that you can actually push the throttle if you load, kind of real time. That I want extra speed, and then when you load it, you can say scale it back. And yeah, it's good to be back to fully featured SQL. That really helps. That's a lovely thing, I would say. And again, buzzwords. I wanted to get to this point, really, because I still feel that I didn't have any buzzwords up until now. Maybe we can have a much interesting conversation also if you understand what we think about buzzwords and how they're coming off. 3 things. And they are interconnected, definitely. I think that we managed to make some kind of prototype for this cloud-agnostic data stack. You could say that it's not there on Google yet. I think I have yet to see more commercial deployments on Google Cloud, if I might say. So let's wait with that. But even if you look at the Gartner diagrams, like, yeah, AWS and Azure, 2 options you have. So this thing you can deploy in either of them, or you can even deploy in like a hybrid way that you have some things here, some things there. You don't care. When tweeting about this Raspberry Pi experiment of collecting Raspberry is just 1 million, no, 6 million events on the Raspberry, there was an answer that this is actually post-cloud, like, the thing. And we were starting to think about that you have this drawer for like screws, if you're doing makey stuff, you know that part. And you have to have this drawer with like Raspberry Pis. That's your server farm. And you say like, this row is for one company. It's like this is data stack, really. And if you look around in Germany, you can even find some funny people who will host your Raspberry Pi for free, forever. I mean, maybe you want to help them and give them like $6 for the hosting, but still, it's something in the realm of possible to make a data stack with that. And yeah, and redneck data, we really, I think, need that kind of down-to-earth approach. I'm an old guy. I'm becoming 40 in a week. I'm always afraid of putting extra layers on top of things, and if something is not behaving in a way I kind of like, putting another extra layer just between it and me. You can call us lazy and stupid and kind of paranoid. It's all true. I'm just like trying to survive in an environment where I understand things and I can debug things still. Because, as I mentioned, if you have like 1.5 engineers, and of the 1.5, 1 is on vacation, maybe, and you got 5 days of data in the queue already, and that queue has a retention of days X, and you're counting back, that's not fun. So redneck data maybe can be based on some kind of this bucolic landscape thing I mentioned. Maybe I go back so you can enjoy it again. So many slides. Boom. So if we can solve it with an X, then let's do it. I don't want to let it loose on the measuring side. So I think we spend most of our time benchmarking things and counting beans and making sure that the beans are actually there. So I think I err on the side that let's measure it with a micrometer and then just like slash it with an X. And let's figure if we can still keep it alive. So like we kind of started out with this setup in a way that we should be fine for us at this scale. And I think we were the most surprised ones to see that actually it kind of could grow with us. I have another picture for you. So many slides. Yes, this is a ferry. If you ever design something, remember this image. This is a ferry. This is not a bridge. This is a ferry. Actually, it's in Germany. But I like engineers. I truly like engineers. But sometimes I feel that maybe you can simplify things a bit. And this one is in production. Thank you. I hope you have some embarrassing questions I cannot answer.
I actually don't need mic. I guess you can hear me. So first I'm also tuning.
Please.
Yeah, okay. So first I'm also lazy, stupid, but that's like with most DevOps engineers, system engineers, system administrators in the past. And I also turning 40 soon. Okay.
We can drink.
Yeah, so that's okay. But I have a practical question.
Yes.
You have RSys log
Yes.
in your diagram.
Yes.
Did you ever had problems with them?
Yes.
Because we exactly been processing engine X logs, and we had like around 30,000 of a customer logs. And at some point, I started blocking I/O completely, and like blocking 1/4 of our instances. Like,
we have problems all over, I think. That's why we try to minimize the number of the moving parts. And that's why we kind of started to get lost of the thing and figured that if we have this Nginx proxy, we can just like clamp on that and get data. Because we had problems. I think first when we started to use RSys log, we really had to map reduce things because things were all over the place. So we slowly and finally just like phased it off. There's no good news for you, sorry.
Hi, interesting talk. How did you find the cost comparing of Azure versus Amazon?
Good question. Sometimes we felt like it's going to be too expensive, but we figured that they are pretty aggressive on pricing, and I like that. That's why we try to help them with benchmarks and say like, hey, this is what I can get on AWS for $2. This costs like $4. Like, can we fix it? And the good thing is that, for instance, the latest benchmark, what we did run on Redshift versus data warehouse, data warehouse was cheaper with like 30%. So I was like, happy.
How is the controlling of the Azure stuff? Do you really need Windows boxes, or can do it from a pure Unix or Mac environment? Starting and all this normal stuff to deploy things and manage things.
Really good question. I forgot to mention this, but for instance, our whole team, except the Windows developers, were originally working on Macintoshes. It's like everybody's. These days, we start to have like more Windows things, but for instance, the data stack is fully in Unix. So there is hope. And it's working, and it's in production.
Other question is, how is about resources? We work on a little bit larger scale than you. We have in our tries in Amazon a lot of resource problems. We have to wait forever to get hosts, or even we don't get our cluster started because they're running out of resources. They give us 48 hours or something like this. They say probably you can start at that time. So we have to negotiate every big cluster run with them to get 800 nodes.
Yeah, I get this.
A crazy number in terms of what you think about a cloud.
Yeah, I think we try to mitigate this with having kind of a breather. We kind of start to have a bit of an overload on this one, kind of start to wake things sooner than they are needed. But they had these problems both on AWS and Azure. Sometimes it's just like hard, really. So we try to get around this in this way, that we try to have some resources waiting to be deployed. And I don't totally see you, but I kind of see in your eyes that with the size of your needs, it could cost a lot of money to have something just sit there in preparation.
Exactly. That is our problem. And Other question is about the object store. We face with S3 a lot of scaling problems. So basically, if you want to have a cluster which has 6,000 tasks in parallel running and writing to S3, you get throttled. So it doesn't work. You have to do this hashing on the first pass of your things that scales. Then you can write it. But if you want to get a directory listing and want to get it work with Hive, it's a nightmare.
Okay.
The question is, do you have on Google Store similar problems that you have to hash your names?
The benchmarks we did run with the Azure Blob Store was like not the premium offering, but like the generic one. And the generic one was a bit faster and more reliable than S3. And I would expect the premium one with some geo-replicated things that could live up to the promises. But I try to get you somebody who is much more well-versed in this one, so I can talk to. So I feel that it's a bit better.
Okay. Because this is something which right now puts a lot of headache to us in terms of scaling.
Why did you have to move to Azure in the first place?
Yeah, good question. I think this was part like, we're part of this big mothership now, we should use those resources. But on the other hand, I think it was kind of, we like crazy things that, let's try if it's possible. And it was possible. And it's really good to be a proper customer inside the company, saying like, and it's really good to hear that they kind of try to answer these questions.
Another question, do you run production workloads on Raspberries? I kind of missed that point.
We didn't put actual production on there, but our testing was pretty okay. So we have a test suite for, actually the test suite is included in the Hamusto thing, you can figure it out by yourself. But it can run production load, definitely. And even the Raspberry benchmark we had, so it was 6 million was the 4 vCPU, and Raspberry was the 1 million event per minute. So the Raspberry benchmark was actually running in a way that the Raspberry was technically on my desk. So it was connected to a router, and so it's not in the cloud at all.
And the last question is, well, in all the buzzwords, I haven't seen Docker. Do you have plans to use Docker?
I'd rather not comment on this issue.
How much RAM does each Raspberry Pi have?
Then?
How much RAM?
I think 2 gigs.
How much RAM? Yeah.
2 gigs.
2 gigs. Okay.
So on the Raspberry topic again, I did some benchmark of Kafka on Raspberry. So we passed like 25,000 messages per second through Raspberries. What was your limitation there? Was it CPU or RAM? Or
RAM.
It was RAM. Okay. Yeah. For us, it was just networking. So and I/O for storing the logs to disk. So it could be possible to get even faster.
I mean, I still kind of consider the Raspberry Pi as the Commodore 64 of our times. So that's why we chosen as the target. But if you go out in the market, you can buy something that's like 10x power of Raspberry Pi and costs like, I don't know, $80. I like these small boxes. They're good.
Very interesting talk. Thanks. Any more questions? No? Then
Thank
it's
you.
lunch. Thanks.
Thank you.